And we're live. Good morning, good afternoon, good evening, everybody. I'm not sure what time it is where you're at. It's morning here, so I got my coffee, having a nice sip here, and I'm super excited as usual. Blockhack has been amazing so far, and we're keeping the ball rolling. We have another amazing chat for you today. We're here with Bruno from Web3 Foundation, and we're going to talk about building a custom front end for your Substrate chain. So before we dive into the actual talk, I like to get to know our presenter a little bit better. So how's it going, Bruno? How are you doing today?
Hey, going pretty well. It's mid-afternoon here, so winding down for the day, but really happy to wrap it up with a nice hackathon chat and demo.
Awesome. It's a pleasure to have you here. So I've been asking folks that have presented like what their aha moment was for blockchain. Like what made you want to get involved in this space?
Well, I'm from Croatia, so just one generation ago, that's my parents' level. The only source of information they had was government-sanctioned TV, government-sanctioned newspapers, government-sanctioned radio. There was no internet yet properly here. So this kind of information asymmetry became really frightening when I saw the modern era deplatforming and censorship going on. If you mix that in with the draconic taxes that we have in Croatia and the hoops we have to jump through to send a simple transaction like across a border, even though we are technically EU, I realized that the old world is kind of too filled with dinosaurs to feed them all, and we should probably just nuke it with a meteor and start over. And so this was my main driver. So I wanted to work on a system which enables anybody to send a message to anyone else in the world whenever they want, and whether that message is financial or just a hello message or just some content that somebody doesn't want you to see, like the Chinese firewall. And so that was my driver.
Awesome. I love seeing like blockchain such a it's a decentralized space. Everybody's coming at it from a different angle, and I love hearing everybody's stories a little bit different. So thank you for sharing that. Cool. So I like to dip into some tangential topics as well and see how people's personal experience informs their work. And so I noticed that you're a fan of VR, as I think a lot of folks here are. But how does that tie into your work with blockchain? Do you think that we're like a Ready Player One kind of future is in our lifetimes, or like what are your thoughts in that area?
Yeah. So I mainly do VR as exercise, but I'm a gamer. I've always been a gamer. I love gaming VR and off VR, and a shared multiverse of games is definitely something that I want, that I think will happen, and that I'm very excited about. The stuff that some projects have been doing, like Engine with their shared universe gaming and their cross-universe items and so on, is definitely a good first step. But I think some of those crypto voxels and other projects took it a step further and added that VR layer on top that really makes it shine. And I think we're not really even waiting for the infrastructure behind it to show up. I think we're more waiting for comfort of the VR headsets so that we can literally be in them for hours at a time. Right now it's not super comfortable, and you can't really read tiny text and so on. Trust me, I know I've spent many hundreds of hours in Elite Dangerous reading very tiny screens in my spaceship. So when we get that ironed out, I think we'll all be owning a little piece of our digital VR land and decorating that. So yeah, it's absolutely very exciting. I am unfortunately not currently working on anything related to VR and blockchain. I do hope to change that sometime in the future, but I remain enthusiastic about it, and I follow all of these achievements very, very carefully.
Awesome. I think one of my favorite games in the VR space is it's called Keep Talking and Nobody Explodes. Have you heard of that
Yeah,
game?
yeah,
It's
yeah, yeah.
such a cool concept. For those of you that haven't seen it, I highly suggest checking it out. It's great for building communication skills. I won't go into how it goes, but I definitely suggest checking it out. Okay, I think we're going to jump into the talk now. But before we do that, for those that have joined us live, I want to draw your attention to the bottom of the screen. There is an Ask a Question button down there. Please feel free to ask questions as we're going through the workshop. We want to keep everybody all caught up, so if you see a question already there that you want to get answered, give it a nice upvote, and we'll make sure that your questions get answered as we go through. Also, directly beside the Ask a Question button, I want to know what your I want to know a bit of things about you, how knowledgeable you are with the Substrate space, and I want to know if you know what Kusama is. It might be a trick question, but we will revisit these questions towards the end and see what you guys are up to. Okay. I think that's it for me. I'm going to pass over the stream to Bruno to take it over, and I want to introduce to you Bruno. He's a blockchain developer and educator from Croatia. He joined the ecosystem full-time in 2015 with the advent of Ethereum and created educational resources, programming courses, tutorials, and newsletters for budding developers in the industry. Since 2018, he's been working on one of the teams building the next generation of Ethereum. And since 2019, he's been a technical educator at the Web3 Foundation, dedicated to forwarding the Web3 vision and helping make sure everyone everywhere has access to the Internet of value and trust. Bruno is passionate about decentralized, censorship-resistant, and transparency coupled with accountability, so he's found his passion in immutable ledgers for the present and future. He holds a master's degree in computer science and English, language, and literature, and likes to dabble in virtual reality when possible. He can be found on Twitter at Bitfalls, which we'll put in the chat, and on Oculus and Steam as The Swader. He also runs a bi-weekly-ish newsletter covering all things Web3, and it's called .leap. So I highly suggest checking out .leap and subscribing to that. Some great information there. And without further delay, I'd like everyone to help me in giving a digital round of applause to Bruno as he takes over the stream.
Woo! Thank you. All right. So let me see how the polls are going. Very few votes, so we'll deal with that later. Today I'm going to have a brief discussion, explanation of Substrate and how it builds and can build its front ends and how you can utilize that. And then we'll have a little demo and we'll try and build however much we can build in a very short time. You can follow along. I recommend, it is not necessary. So to play with Substrate, you would generally have to have Rust installed and a lot of different tools on your system to compile a program that you're playing with, to compile a blockchain that you can play with. But that takes a lot of time. So if you were to start that from scratch and if you don't have anything, it'll take something like 40 minutes on the laptop total. On a semi-powerful desktop rig, it'll take like 10 to 15 minutes. But I really don't want to bother you with this. So I recommend that if you want to follow along, you should at the very least on your computer have installed a recent version of Node.js. And if you're on Windows by any chance, then I recommend using NVM, which is the Node version manager. And that'll let you dynamically switch between node versions so that you can use the latest features, or if something's old, then you can switch to an older one. And also Yarn, which is the package manager for Node.js, which will help us install some things and serve our front end that we'll be building. Generally, I'm not a very big fan of complicating workflows. I was a web developer for some 10 to 15 years before joining the blockchain space. And I am from the old school, old guard of cash is king, and I don't need 150 megabytes of tool chains to build my static website. So I prefer going in raw and doing HTML and JS or TypeScript or whatever without having to go through a chain of 50 to 70 tools that will compile and transpile and otherwise merge my files. A competent developer should know how to work without those. That said, if we have to use a framework, and most people insist on them, I do prefer Vue.js purely out of two reasons. One is that the current ecosystem is kind of dominated by ReactJS, and I really like diversity, so I want to give developers more options. And the second reason is that ReactJS is made by a comically evil mega corporation, and using it indirectly supports them. So I just want to, add some diversity into that toolset and also, encourage some independent development, which is what Vue.js is. So we'll be using Vue.js later on, but I'll explain how, why, and what the other options are. Now let me share my screen with you, and we'll get started with a very short presentation here before we dive in. Just a second, let me figure this here out. All right. Okay, so we will be building a custom frontend for a Substrate chain, and actually I'll share a link with you later so you can join this. So about me, my name is Bruno. I'm a technical educator at the Web3 Foundation. My job is basically copy pasting. I copy knowledge from somebody else's head and paste it into somebody else's head. My mission is to demystify complex things so that people can dive into our technology stack and build things that they find interesting, and that's really it. I build proofs of concept, I build experiments, and I verify that what other people have built works. Help people get onboarded into this ecosystem and so on. So you will rarely find me producing any kind of final product for production, because I'll usually get things started, get a prototype out, and then somebody will take it over. As an example, I can show you something that I recently built, and that's called the Remark app. So Remark is a way to force Kusama, which is not a smart contract blockchain, to have NFTs, non-fungible tokens. And this is something I invite you to play with, because the specifications for using this are live, and the tools I'm still developing. And it essentially uses a method of graffitiing the chain. So every Substrate chain has the ability to emit graffiti into the chain, and any node that's running that chain will be able to see that graffiti. So if you're familiar with colored coins from Bitcoin from way back when, this is the same approach, right? You write a custom message into the blockchain that somebody who reads it can parse it in a specific way. And then that parsing takes on a special meaning. So this is the same thing with the NFTs that I forced onto Kusama. And we'll talk about Kusama a little bit later. But keep in mind that remark.app is definitely not something for production that you should put a lot of value in, but it's definitely fine to play with and experiment with, and I encourage you to try it out and get in touch if you build something interesting. I would definitely like to cooperate there. This is one of those rare ones that I intend to maintain for a long time. So that said, get in touch with me through Twitter, Telegram, LinkedIn, email, whatever you want. Email is bruno@web3.foundation. I'm very happy to talk to anybody about any project you have, any idea you have. If you get stuck on something, I'll help you brainstorm it. I really want to get this developer ecosystem, build it up and help developers get on board with all of this stuff. That's Bruno at web3.foundation, not Bruno at web3foundation.com. So that's it about me. Get in touch for anything that you might want to know. In terms of today's presentation, whenever you have a question, put it in the Ask a Question box. I'm keeping an eye on it. Whenever I see a question, I will pause and answer it, because I like answering questions as they pop up, because they're usually the most relevant then when they pop up. So we won't leave them until the end. So just put it there, and I'll try to jump in. All right. Let's get started with Substrate as a basic explanation. So from what I hear, you had already an introduction into Substrate, so I won't go into too many details, but I want to just cover how it works and why it lets us do what we are going to do later. Substrate is a framework for building blockchains. And you can think of Substrate as a big Lego board of no components, no elements, but that Lego board itself has some functionality. So that Lego board has a database, it has a transaction queue, it has a consensus mechanism, but it also comes with a bunch of modules. So those are the blocks that you add onto the board, and we call those pallets. And the standard under which those pallets are developed is called frame. None of this is important. You don't need to remember these names, these terms, but you do need to know that all the custom functionality that different substrate-based blockchains have is mainly inherited from these different pallets that are already pre-built. And of course, you can build your own custom pallets, and Substrate is actually developed in a way that lets you very easily build your own custom pallets. We have a bunch of tutorials for that, and I'll share some resources at the end for that. Remind me if I forget. The trick is that Substrate itself is like a language, or is a domain-specific language on its own, in that it's based on macros. And macros are magical pieces of code that create more code from less code. So I can write 200 lines of code doing something in Substrate, and during compilation, those 200 lines of code will become 800 or so lines of code when they're expanded by that macro. So basically, you have a bunch of shortcuts that let you do specifically what you want to do with that blockchain. And that's why it's easy to write, relatively easy to write custom pallets for your blockchain. Of course, there are things to keep in mind, and there are some tricks and caveats, and all of this is still being ironed out. But this was created by Parity, and that's the dev shop that's building Polkadot and Kusama and the other chains. And this was created because in the past they had created blockchains for enterprises, companies, and so on multiple times, and they realized that, hey, like, why are we again reinventing the wheel? We have done this a dozen times already. Let's abstract it. So they built a framework that can do these repetitive steps for them. So it just adds on the networking layer, the database, the whatever, and the basics are there. You download that, you run that, you already have a blockchain. And then all you have to do is add in the custom functionality. And it just so turned out that this entire process, this abstraction of all of these complexities, so that you don't have to spend 2 years or so doing research and development on your own blockchain's base stack, this has been so audited and so battle-proofed that we now have over 100 chains being developed based on Substrate. Polkadot itself and Kusama are based on Substrate. And Substrate has become kind of like the de facto standard for you to start your blockchain from. Because it's so raw, it's so open when you first install it, when you first power it up, that you have been kind of saved from a year of just bike shedding and doing virtually just reinventing the wheel on everything that's been built previously. And you can dive into the application-specific logic of your chain right then and there. And this is why we also have some tutorials that are optimized to help you create your blockchain in under an hour. I actually have a bunch of video tutorials as well, and if you go to substrate.dev/tutorials, you'll find a bunch of them there. If you just go through the first 4, you will it'll take you around 2 hours, I think, for the first 4 tutorials. But after those 4 tutorials, you will have built a blockchain, I think, 3 times, and you will have installed a custom module in them. You will have written your own module, and you will have been running it on your own machine and connecting a custom, not a custom, but a template front end to it. And there's some more magic in there, as you'll see. But what you need to remember is that Substrate is the foundation on which all of these blockchains are built, and it's based on a subset, a kind of a sub-language of Rust, so that it's full of shortcuts for you to use that have been audited out of their mind. It's very, very difficult for something to go wrong there in these base components, because there's like, I don't think there's a blockchain system that's more in production than Substrate's core stack right now. So we also have, if you will be interested in building on Substrate and you get stuck, because admittedly Rust is not the simplest language to learn, and learning Rust through Substrate is kind of like learning JavaScript through jQuery. So not exactly full of best practices, especially because the syntax differs. You know, a macro can contain any syntax you want because it's a macro, so you get to define the rules of this language. And so that doesn't match the raw Rust, really. So it's not, if you don't have any experience in Rust, it can be confusing to get started. But you might have an awesome idea and a good starting point, in which case the Substrate Builders program would be of great help. That's a program where Parity itself, so the dev shop that's building all of this, literally handholds you until you launch your thing. So they will be available for free consulting whenever you need it, and they will help you get your thing out the door. They will teach you how to code this, as long as you have a good plan, a serious idea, and a dedicated team to do this. So consider that option if you want to go down the Substrate route. Now, why would you want to build yet another blockchain in a sea of hundreds and hundreds of blockchains out there? Isn't the space saturated enough? Yes and no. If you were to build a hold on, I see a question. What's the best way to learn Rust? Go to Rust's website, open the Rust book, and go one by one chapter. So they have an excellent book there. It is well documented, with full of examples. It's huge. It'll take a while to get through, and it'll take you like a year to become proficient. But it's the best way to learn Rust. That said, learning Rust is not going to help you learn Substrate, so then you'll have to learn Substrate on top of it. I would actually recommend that if you're in this only for the blockchain game, for the Substrate part, to start with Substrate. And then as you run into walls that Substrate cannot help you scale, dive into Rust and see if you can modify the macros that Substrate is throwing out. That in my opinion is the best way. So yeah, there's a link in the chat now to the Substrate Builders program. It's literally a program to help you launch your thing, and it will teach you what you need to know, but you need to pass the interview process of being a good project, right? They're not gonna dedicate resources to just about anybody, so you need to have a good idea and a good plan, and if you do, then you will be onboarded into this. Now, in terms of Polkadot and Kusama, so let's see if there's any more comments here. Okay, a canary network. Good. Three out of 15 people voted that Kusama is a canary network for Polkadot. Yes. Excuse me. So Kusama and Polkadot are both based on Substrate. Polkadot, as you might know, is a blockchain that is meant to connect other blockchains. So what I was saying in terms of why would you build yet another blockchain? If you're building an independent blockchain that has its own economy, security, token, and so on, the space is kind of saturated, and it's very hard to find a justified reason to do that unless it's a very niche thing to do and you already have like a user base that's interested in maintaining that chain. But Polkadot as a chain that's designed to help other chains communicate, it allows you to connect your custom chain to Polkadot, and through Polkadot to get messaging capability to any other connected chain. And additionally, when you have a chain that's connected to Polkadot, you no longer need to have your own consensus mechanism. You no longer need to have your own security. You don't need your own validators or your miners, because the validators on the Polkadot network are securing all the connected chains. And so by adding one chain, by each new chain that enters the system, that connects to the whole system, makes the whole system more secure, because in order to enter that chain, in order to enter that ecosystem, a chain needs to lease a slot and attach to that slot like a plug. And by leasing a slot, they lock some tokens up for a given amount of time, 6 months to 2 years. If they do that, then they take those tokens off the public market, they reduce liquidity, and they make things more expensive. By making things more expensive, they increase the economic lock-in value of the entire validator set that's securing all the chains, and they essentially help the entire ecosystem be more secure because there's fewer DOT in circulation. Kusama is the same thing, so it allows other chains to connect through Kusama, but Kusama was originally developed as a canary network. Sorry, there's a question. Can Substrate connect with Bitcoin Cash? Yes. So let me just finish on Kusama and then I'll clarify that. So Kusama was originally developed as a canary network and deployed from the same source code as Polkadot, but it was deployed a year earlier than Polkadot and was intended to be the canary in the coal mine. So anything that would eventually make its way onto Polkadot would first be test driven on Kusama. That doesn't mean that Kusama is a test net. In fact, we wanted to give it economic value so that people would be incentivized to break it. Because if you have nothing to gain by breaking a system, then you're not going to try to break it in most cases. So Kusama was envisioned as a canary network with real economic value and its own ecosystem of users that would eventually diverge from Polkadot. And this actually happened. The two networks are quite different at this point, with different user bases, different purposes, and different priorities. We still do first deploy things on Kusama, but there are some edgier things that find their home on Kusama that would never work on Polkadot. And Polkadot is also 4 times slower than Kusama in terms of delays affected by the network. So for example, when you have on-chain governance, as all Substrate chains can have, then on Kusama, you need 7 days to make a decision, 7 days for a voting process, while on Polkadot, it's 28 days. So Polkadot is like the more conservative cousin, right? And Kusama is edgy. If you want to make a comparison in the creative world, Kusama is like your garage band, which you get together with your friends, you play some music, some people show up because they hear something, somebody brings beers, everybody has a good time, a crowd gathers, it's fun, people can change the playlist set while they're playing, doesn't matter, maybe somebody's gonna spill a beer over a speaker, doesn't matter, everybody's gonna have a blast and go home in the morning. With Polkadot, it's a symphony. It's very difficult to change a symphony. You need buy-in from the conductor, you need buy-in from the orchestra, you need buy-in from the venue, you need buy-in from the audience that already pre-purchased tickets and so on. So it's very difficult to change. You need a lot of people's agreement on it, and it'll take much longer to change it, but the skills that you may have rehearsed as a garage band player will come in handy in terms of music quality when you join an orchestra perhaps. So the two are different in that way, but they are still based on the same source code with minor differences. For example, on Kusama, there is a crazy society like a decentralized autonomous organization on chain, which lets you join it if you get a tattoo of the chain's logo, literally a tattoo. And then you have proof of ink where you need to prove that you've been inked, and you will be let in. And if you do that, you will be rewarded from the society's treasury, which periodically refills, so you will get money to get a tattoo of the chain. I think there's like 40 members right now, so 40 people with tattoos. And the idea is to build a human blockchain, because every new tattoo must have a reference to the account index of the previous last member. So every new member that joins needs to tattoo an index of the previous newest member so that you form a human blockchain of tattoos, which is interesting and crazy and would never work on Polkadot. But on Kusama, it's more than welcome because that's how Kusama rolls. And the same goes for the Remark app that I shared earlier. So Remark app uses those chain graffiti to put messages into the chain and interpret them in a different way. This is creative abuse of the network, and it wouldn't fly in Polkadot. People wouldn't like it. But on Kusama, it's more than welcome. It's creative. It's arguably useful when it launches like properly in production. And it's a nice proof of concept of what's possible with a blockchain that is logically kind of limited. So yeah, in terms of can Substrate connect to Bitcoin Cash, when chains that already exist need to connect to Polkadot or Kusama, they need to use bridges. When you're building with Substrate, you have the ability to activate Cumulus, and Cumulus is a plugin for Substrate chains, which lets you automatically be compatible with Polkadot, so you can connect it directly. Because by default, a Substrate chain is its own chain. So it's not opinionated. It doesn't want you to join Polkadot. It just lets you build an awesome blockchain. If you want to connect it to Polkadot or Kusama, you activate the Cumulus plugin, which is 2 lines of code. You add it in, and then you are automatically compatible with Polkadot. The Substrate-based chains that want to connect to Polkadot, or any chain that wants to connect to Polkadot, doesn't have to be Substrate-based. As long as it has a function signature that matches the one that the relay chain, so that's the main chain of Polkadot or Kusama, requires of them, which means that signature looks something like input data, output data, state transition function. So you send in the starting data and the ending data, and the relay chain is aware of the state transition function, of the logic that will turn the starting data into the ending data. And if the chain exposes this information to Kusama or Polkadot, and Kusama or Polkadot can verify that information, then they're automatically compatible with the chain, right? So they can automatically connect. Now, other blockchains like Bitcoin Cash and Ethereum and whatever else, they don't communicate in this format by default. They don't expose this information by default, so they cannot be understood by these relay chains that they would connect to. To accomplish this, you need bridges, and bridges are like chains they will occupy one of those slots that I mentioned. And that bridge, the only purpose of that bridge will be to translate the information from, in this example, Bitcoin Cash, into the format that the relay chain can understand. So the bridge will have a translator, an adapter function inside it that will basically take transactions from the Bitcoin Cash blockchain and translate them from block to block. So this block had this input, this block had this state, and then in between you have the state transition function that you can apply and see that this actually checks out. And in that format, the relay chain will be able to understand Bitcoin Cash and will be able to make it communicate with all the other connected blockchains. So yes, existing blockchains can connect to Polkadot and Kusama, but they will need bridges. In terms of connecting just Substrate itself to Bitcoin Cash, you can totally do that already. There are some bridges under development and being made. You can play with them, but there's not much use in connecting Substrate to Bitcoin Cash per se. You have much more use of connecting Bitcoin Cash to Polkadot or Kusama so that you get exposure to the functionality of all the other connected chains, right? Why does Kusama have its own token, KSM? Why not just use DOT? Feels like a Russian doll. So Kusama is a separate blockchain and Polkadot is a separate blockchain. They cannot have the same token by definition, and they are two different communities, two different blockchains with different purposes. It wouldn't make sense to have the same token, especially because Kusama is a year older than Polkadot. And additionally, DOT was sold in the ICO back in 2017, KSM was not. So these are two completely different economic and logical systems that also have completely different end goals in mind, completely different economies, completely different user bases that will eventually flock to them. So they are not exactly compatible. That said, Kusama could theoretically connect to Polkadot itself. They could connect to each other, There are no plans to do that right now because there's no reason to do that right now, but it's technically possible. But the tokens will definitely remain because Kusama is secured by its own set of validators and Polkadot is secured by its own set of validators. The validators of Kusama will stake KSM and the validators of Polkadot will stake DOT tokens. So these are not compatible at all. Okay, so now that we've covered the basics of Substrate and the chains that are built on them, and these are just the two main chains, right? There's 100 blockchains in production or so, in development or so, that are using Substrate and are trying to build stuff. There are NFT specific chains, there are DeFi specific chains, there's a bunch of their gaming specific chains. In fact, I think you can find most of them if you go to polkaproject.com. You'll find some interesting chains there for inspiration, so you can check that out. In terms of the special sauce that makes Substrate work and it makes it awesome, it's that every Substrate chain is has its runtime, right? And the runtime is what actually is used to go from one state to another state, from one block to another block. That's called the state transition function, which helps you get from block A to block B and process the transactions in between. And you can use this Lego approach to build a custom runtime of your own. So in this example, you see here that we have a runtime up above composed of the pink marked palettes down below in the table. So this runtime has babe, balances, grandpa, indices, pseudo, timestamp, and system. And these palettes are then taken, put into this runtime and compiled. And now, each of these palettes has a very specific use case. Balances is used for basic cryptocurrency stuff, so balance tracking, transactions, and so on. Indices allows you to register a short version, an index of your account, so that people can send you money, send you tokens through that index. It's kind of like ENS, but you don't get to pick the string that represents you. It's just an index in the database. So you can get like an A0G instead of a long string of 30 letters and numbers, right? Pseudo is one palette that lets you have administrative power over a blockchain. So a single address will be able to do admin stuff. And when it's removed, then the chain is decentralized. Now, how is it removed? Well, the Substrate magic is in when you compile Substrate, you get two things. You get a binary distribution, you get a binary program that you can run, and you get a WebAssembly blob. And WebAssembly is this binary format that can be interpreted in a lot of different runtimes and that can run in a lot of different environments. And so when we get WebAssembly code, that's put on the chain directly. So it's uploaded to the chain itself. And so you end up with two things. You end up with a WebAssembly blob on the chain, and you end up with a runnable program, a node. So when you're running a node, that node is going to be running whatever source code, whatever runtime it has compiled in itself, and it's going to connect to a chain. But then when if it by any chance notices that the WebAssembly code on the chain has a newer version than whatever it's running natively, it'll just switch to the newer version on chain and it'll run the WebAssembly code. Now you can upgrade your node to also natively contain the updated changes from WebAssembly, because usually the new WebAssembly is the result of a compilation, and the compilation will result in a new node as well, which has natively the same version as the WebAssembly code that's being uploaded. But why this is useful is you don't have to upgrade your program. You don't have to replace your node. If your node is running, when it notices a new WebAssembly version, it'll automatically download that code and run it. This means forkless upgrades. So if I want to upgrade my blockchain and add a new crypto primitive, or add a new palette into the mix, or remove a palette like pseudo or something, all I have to do is do that locally, compile my program, and upload the WebAssembly result of that compilation. If that WebAssembly is voted into the chain through on-chain governance, where all the token holders can vote yes or no, if it's voted in, it will automatically take effect. There's no need to call anybody. There's no need to put together dev calls and argue that people should upgrade or there will be a fork or whatever. It happens automatically. There's a certain block at which the WASM, the WebAssembly, will become enforced, and it will automatically become activated when that block is reached. And that new logic will automatically come into effect. This can be anything from simple changes like changing the maximum number of validators in the system to major complex changes that even change out the consensus layer itself. So this can be as custom as you want it. And when that's confirmed, your chain forklessly upgrades, which means that you can leave your node unattended and it'll just follow along and download new versions of WebAssembly as they happen on chain. Now you can also upgrade your node when you feel like it, because that just gives you a performance boost. Native code is always faster than running the interpreted WebAssembly code. But that's, the performance boost here is minor and completely useless for regular users. Maybe if you're a validator, you might suffer some latency because of this. So as a validator, you're encouraged to update often and keep an eye on new versions. But as a regular user, you do not have to worry about this. If you run your node on a Raspberry Pi in a closet, you can leave it there for months. It'll be fine. Occasionally, there will be big breaking changes that need a node upgrade or something like that. This happened in the early stages of Kusama because it was a canary network and we were doing a lot of crazy experiments. But this hasn't happened in over a year and never on Polkadot. So you can just leave your node running and it just works. And this kind of this upgrade process makes everything much smoother and makes it way easier to iteratively develop your chain. You don't have to plan big updates and bundle them all into one big upgrade because you have to, whip all the members into upgrading their nodes, like currently in Bitcoin or Ethereum. Instead, you can do smaller upgrades and add them to the chain as WebAssembly and get that out there, piece by piece. You don't have to make these mega updates that in which 1% of the changes might fail, and then you have a whole problem on your hands. So this is very useful for Substrate, and every Substrate blockchain has this ability, can do this forkless upgrade, including Polkadot and Kusama. One other very useful thing that Substrate allows is the exposure of metadata. So you have your data that you can connect to. You can read and write data to the chain through RPC, through APIs, through whatever library you're using and tool and user interface and whatnot. But you have to know what you can do, how you can submit that data, and so on. And usually that requires a lot of documenting on the part of the project maintainers. In Substrate, things are a little bit easier. Substrate chains expose metadata by default, and metadata about a chain is literally a 400 kilobytes or so JSON file, which documents meticulously from the source code itself which methods, functions, errors, events, arguments, everything that's possible, types, everything that you can encounter in that chain in terms of logic is documented and exposed through this metadata in a standardized format. So what good is that? Well, you can build a single UI which relies on that metadata and then modify what the UI exposes to users based on what the metadata gives you. As an example, if you go to Polkadot JS Apps. So Polkadot JS Apps is actually, let me show you live if I can. So you can see here, this is the Polkadot JS Apps UI. I am now connected to the Rococo testnet. And the Rococo testnet is a testnet for testing parachains. We are launching that functionality very soon. And this one is used to test parachains, right? So now you can see here the Rococo testnet. Under network, we have the option for parachains. If I check out parachains, you will see a bunch of parachains. They're currently only listed by their ID, so this UI still needs work. So they have this basic data about them, what they're currently doing. These are the chains connected to the master chain. If I switch this network to, for example, Polkadot, I'm now connected to Polkadot with the same UI. I just changed the endpoint that I'm connected to. And if I check this out, network, there's no longer parachains, but we now have staking, right? So the UI changed based on what the metadata of the chain told it. And like we have accounts here, network, governance, typical options. But then if I change to Edgeware, you'll now notice that we have here contracts. So now we can do smart contracts, right? Edgeware is a smart contract parachain which uses Ink, which is a again a DSL based on DSL written in Rust. So it's a Rust-based smart contract language. And Edgeware, which is currently a standalone chain and aims to become a parachain, a connected chain later on for Polkadot and Kusama. Edgeware integrates the contract functionality so that you can write smart contracts on it. And you can see this option was not available in Rococo or Polkadot. It's only available on Edgeware because Edgeware supports it, right? In fact, if you want to see the metadata of your of the chain that you are using, you can go to, and if I'm not mistaken, that was under system. No, it's not system. It was under, where was it? I keep forgetting where this is. Maybe under Substrate. It's not Substrate. It might be under constants. System. Yeah, I can't remember where it is right now. Or it's under RPC calls. Yeah, chain and... No, not chain. It was system. Damn it. Hold on. I'll find it. I'll find it if it's the last thing I do. Transact contracts, off-chain payment, RPC. Must be under system. No, it's not here either. I don't know. I'll let you know. But anyway, you can find all the data, all the information about your chain under this developer screen. So this applies to all the Substrate chain. They will have everything that you need to know under this menu. So if I want to find out the properties of this chain, I can see here that these are the properties of the chain. This means that this is how many token decimals this token has, so the EDG token of the chain. SS58 format is just the format of how the account addresses are displayed and the token symbol. So this is one bit of information that you can find out about the chain. There's a bunch of other stuff as well, but I can't remember where the metadata is right now. But it's in general it should be under chain state. Just that I've missed something for sure. Balances. Doesn't matter. I don't want to waste time on this. I encourage you to explore this user interface. So it's all on polkadot.js.org/apps, and you can connect to all of these chains in the sidebar. So these are the chains that are live right now. These are the chains that are live. There's a bunch more in production on polkaproject.com. You can see if you activate the Substrate filter, you will see a bunch of Substrate based, there we go, 84 chains listed as being based on Substrate. You can check those out for some more details. So Polkadot JS Apps is this UI that is open source that you can download, and that has everything and the kitchen sink. So you will have absolutely every bit of functionality that's ever been developed for any chain will be included here. A bunch of UI shortcuts. It's for power users. It's not for the faint of heart. It's not for normies. You do not want to inflict Polkadot JS Apps UI on normal people. You can use it for testing. It's very good for testing. But I wouldn't recommend putting it out there as a production UI for your user interface. A better option is the Substrate frontend template, which is a ReactJS project with some pre-built components to upgrade runtime, query the storage, and make transactions. It also uses the Polkadot JS API. So right now there's only one API in production, an API library that is like feature complete, and that's the Polkadot JS API, and everybody virtually uses that. It's a very good library, but it's quite heavy at times. It's very difficult to package into browsers. So you have to be selective in your modules and your building of the JavaScript app when you're doing this, which is difficult to pull off without those package managers that I mentioned. So package managers will extract the packages that you need out of this and will mostly ignore the stuff that you don't need. This is quick to extend and add new functionality. So this is a good starting point if you're building a custom UI for your blockchain. I recommend checking this out, and I think the third or second tutorial on substrate.dev will teach you how to use this. We'll have you deploy this, or maybe even the first tutorial. We'll show you how to power up a basic front-end template. You're not going to customize it, but you're going to power it up and you're going to see what's happening here. Now, the third option that I want to demo here today is Polkadot. And Polkadot is the Vue.js based starter kit. It comes with block reading out of the box configured for you, so you can see some basic interactions with the chain. And there are some component tutorials on .leap.com. So .leap.com is the website where I try to host tutorials for web developers to join the Web3 ecosystem. And I use Polkadot mostly for examples so that people can get started quickly and interact with any Substrate chain using this Polkadot thing. .leap.com is the tutorial site. The newsletter is .leap.substack.com, but also there's a newsletter link on .leap.com if you want to subscribe to it. So let's get started with doing this. Now, before we clone and use Polkadot, I would like you to, if you want to follow along, I would like you to download a binary release of Polkadot so that you can run your own Polkadot chain locally. You can do this by going to releases of Polkadot, and I'm going to paste that into the chat. So the version 0825 will come, if you scroll down a little bit, with the Polkadot binary. So it's just this 68 megabyte file. If you just download that, that's going to work on any Ubuntu or Linux distribution. At least it should. It won't work on Mac OS. So if you're on Mac, I recommend just not doing this and using the live endpoint for Polkadot that Polkadot will default to. But if you are on something Linux based, you can use this. It doesn't matter either way. It's just going to be a little easier to use if you have something running locally, because if you're connecting to a live endpoint like this one, then you don't actually have the ability to reset the database, reset the chain, write nonsense into it without spending money and so on. You can still do this if you follow the first tutorial on substrate.dev, but not now. So this will require, I'll share this here. So this tutorial will require you to set up your environment in terms of Rust and stuff. And when you compile the node template, you will end up with your own chain as well, locally on your computer. But it's not going to have all the functionality of Polkadot, because that's the node template from which people build their own chains. But it's going to be just as useful for this use case that we'll be going through. So I have here, actually, let me try and zoom in here a little bit. Okay, so I have here a download of Polkadot 0824. So I'm not on 0825. Doesn't matter which one you use. Either is fine, because we're using a local copy of these tools. If you downloaded it and unzipped it, you run it by just running Polkadot 0824 or whatever your file is called, and then you pass in the dev flag. So --dev. The dev flag will run this in development mode, which means it won't connect to the live Polkadot network. If you run it without the dev flag, it'll connect to the live Polkadot network and start syncing the network. This is going to take a while and is not very useful when you're doing local development. So do --dev. If you click this now, you'll see the output starting to produce some logging lines. And in this case, you can see here new epoch 1 is launching, which means that we are starting, there we go, imported block 2. We have started a new blockchain. So what can we do with it? And your output will probably look a lot better than this because emojis are not supported on my emulator of the command line here. I'm on Windows. In almost all other environments, it's way better. It looks quite nice.
Hey Bruno, can you give us a bit of a zoom on your terminal there, please?
Oh, even more? Sure. Let me just figure out how to. Okay, let's give it full width. Hey, this is not 100%. What's up? Normal, full screen, no, maximized, normal. Aha, 100%, sir. There we go. There, and now I can increase the size, the height as well. And that's gonna be something like 20 lines. And now we can zoom it in. How's this?
A lot better, thank you so much.
Awesome. Okay, so now we have the logging output, and you can see here imported some number means on which block we are. And when you're running your chain locally, and let me know in the chat if you need me to slow down or give you some commands or whatever. When you're running your chain locally, you can already connect to it from the hosted version of Polkadot JS apps. So if I go here down to development in the chain switcher, so I'm on the Polkadot JS Apps UI, right? If I go down here to development and switch to local node, which defaults to 127.0.0.1.9944, I click switch, I am immediately connected to my local version of Polkadot. You can see here the number of blocks is rising. I'm on block 21. Explore, I'm now on block 22. You can explore each individual block in terms of what happened inside of it. Let me zoom this in as well. So you can see everything that happened in a block, and you can use everything that Polkadot has, but locally. So you can play with this as much as you want. And since it's a dev version of the chain, if I go to accounts, I'm going to have a bunch of accounts that are pre-loaded with a bunch of money. So you can test this locally. You can test drive Polkadot functionality locally when you're running this. And your chain is not connecting to anything else. You can just experiment with it. But like I said, this is super complicated in terms of a UI, right? You do not want to use this as a kind of like a final product to give to your users. This is for development purposes. It's great. It's not that great for a final product. So let's do, while the chain is running, now in another tab, I have my Polkadot clone. And to get to Polkadot, you would do, let me share the link. So this is how you get it. You just go to git clone Polkadot.link, then you cd into Polkadot, run yarn as a installer of the dependencies, and once it's installed, you can run yarn serve. If you prefix this command with port equals something, then it's just going to serve it on that port. Let me show you this. So port equals 8081, yarn serve. Now it's going to start the development server. It's working to build the app and package up the JavaScript stuff that's in there. You can see that this takes a while. So JavaScript heaviness of 2020 in action. But there you go, compiled successfully. And now it's running locally and on your local network. So this is configured to make it extremely easy to test your stuff on mobile devices or on other devices in your local network. If you connect to this URL, you'll be able to visit this same running thing on any device that you own. We'll use localhost for now, so let's see about that. Localhost 8081. There we go. So now I'm connected to my local version here, up here, and that's because I was previously using this. So for me, it defaulted to my local version. Let me zoom this in as well. So for me, it defaulted to the local WebSocket of my running chain. But you have some presets here. One of those will be Kusama and the other will be Polkadot. So if I go to block number, you can see that the block number output of my chain locally matches this one. So this one is already on 52, but it matches the block number of my local chain. But if I switch to Kusama, then you will see that we are on 4,673,522 block number as Kusama, and the color changed a little bit to represent that you're on a different chain. On Polkadot, the same thing happens. We're now on block 2.2 million and it changed to blue. When I'm connected to my local network, it also is blue because this in effect is Polkadot. So it checks the metadata for the name of the chain, and if it matches Polkadot, it'll be blue. And since we're running a local version of Polkadot, it'll be blue. So what can we do here? Let's first look at how this actually looks in the code. So if we go to the block number component, so every component is defined in source pages. Every tab that you see here is defined in source pages. So this dashboard is just a collection of charts that don't do anything. This is just for inspiration, so you can use it when you download Polkadot. And home also doesn't do much. It just describes what this is and how you use it. So let's take a look at the block number page, and you can see in the URL it changes to block number pages, and then we have block number.view. Now in Vue.js, if you're not familiar with it, every component is contained in one file. So a single Vue file will have the template for that component, will have the JavaScript for that component, and will have the style for that component. This makes it possible to share components between different deployments. So if you take Polkadot and build a new page that connects to Substrate and does something, you will be able to just copy and paste that page to somebody else, and they will immediately have it working. They can just add it to their app. In this case, you can see that block number has this template, and it outputs this block number. So that's the value that we are seeing here. And in the JavaScript part of it, we can see here that we are importing the API, and the API is just the connection to a Substrate chain based on the parameter that we have defined in this selector. Excuse me.
Hey Bruno, can you give us a little zoom on VS Code, please?
Yes, of course. Thank you. Hold on. Better?
Yes, definitely better. Thank you.
Okay. So you can see here that this template is exposing the block number as a template, and that's being replaced by the JavaScript part. So here we are importing the card element, and the card is just a visual element for exposing some data. So every set of information on page is in a card. This is just for layouts. And API is being imported from the connection.js file. And the connection.js file is just a bootstrap file that basically connects to whatever you put into that drop-down selector. So with connection.js, it's fairly simple. It'll default to Polkadot Live, and if you change it to anything else, it'll default to that which you changed it from that moment on. So if you change it to your own chain, every refresh is just gonna be reading from your own chain. So it imports this API that's ready to be used, and then we have the typical exporting of methods and data of a Vue component. So you don't have to understand all of this. I have some tutorials on .leap.com which will help you understand the elements of this. But what it does is when this component is created, that means when you open this page, when you open that tab, then call the function this get block number. And that's just methods get block number. This refers to this component, and the method get block number of this is this function here. And then API then, because API needs to resolve. API is a promise. If you're not familiar with promises, that's just a JavaScript function that will happen, that will end in the future. So what this logic says is, when the API is ready, then use this API to ask the chain via RPC about the block, about the current block. Then, when you get a response about the current block, use that block value that you got to extract the block number. This is how you extract the block number. So you enter the block and the header and turn that into a number. It's kind of convoluted, but that's how the API is built. And then set this component's block number property to that value. So this component has the property block number, and events, that's a remnant from another tutorial, doesn't matter. So block number is set to 0 by default, but this function, when it's created and called, will overwrite this 0 value with the actual block value. And that's all there is. And this will automatically be updated to the latest block number. Now, we can modify this. It's very easy to clone these components and modify them to do something that you would like to do. So as an example, let's see how we can subscribe to chain events. And chain events, let me show you. If you go to the Explorer and visit the block, you can see here you have extrinsics and events. Extrinsics are inputs to the chain, are commands to the chain that cause some kind of a change on the chain. So these are like external commands that you issue to the chain. And remember that remark app that I told you about? So the system remark extrinsic is what's used to graffiti the chain. And in fact, I can demo this for you right now. So if we go to extrinsics, we use the Alice account, which is the unlocked God account, and we pick system as the module from which to call the function. And then there's the remark ability here. And here you can put some information. So let's say I will put down the hash 0x1337. And I can submit this transaction, sign and submit. It's block 124. So in block 125, we should see this. All right, let's see. Explorer, block 125. There we go. So we had the following extrinsics submitted in this block. Timestamp set, so that the block knows when it happened. Finality tracker, so that the chain is finalized. This is automatic because we are in God mode, in developer mode, so this will always happen. And our system remark. The system remark lists what we did, and now anybody who's running a node of this chain, currently just me, but anybody who would connect to this would also be able to see this system remark at block 125. And this is how the remarks work. And then you have the matching events for these things here. So technically this is a balance of 0 that when you issue transactions in Polkadot and Kusama, the transaction fee is sent to the treasury, to the on-chain treasury. So that's a special account on the chain that collects money and then can fund the ecosystem based on some democratic decisions. So these funds are typically deposited into the treasury, but since this was a cheap remark that didn't cost anything, there was nothing to deposit. And we have here the event was system extrinsic success, which means that this was successfully written to the chain. And if this weren't a success, then it would be extrinsic failed or something like that. So this is how you put these remarks on chain, and this is how they are exposed inside of the event, inside of the block. And every block will have at least a few events happening, at the very least for the timestamp set thing, where the block just saves the time at which it was created, so that you have some kind of a basis in human time for when each block was created. So let's subscribe to events as they come in from the blocks, right? Let's make it display on screen when events are happening. There's a few things that we need to do. First of all, we will copy the block number file, and we will put this into pages. So let's make a new tab that will display our events, right? Let's paste this in. Let's call this events.view. Okay, so let's rename this as events, and outputs the events as they come in. All right, so let's call this just placeholder for now, because we don't really know what we're going to put here, and we can remove this method. We're not going to need this method here. This is fine. API is defined but never used. This is also fine, and we can maybe, okay, let's keep these around. These are fine. When the component is created, we will be subscribing to new events. So events as they happen, you can subscribe to them. You can make them notify you of when they are happening. So we'll create here an empty function called subscribe, and it's just gonna wait for us here, right? And then we are going to do something like this: subscribe. So when it's created, we want the page that we're on to subscribe to new events from our chain. Let me know if you need me to scroll up and down or something if you're following along. I want to help you, get this done as well. Now there are two kind of awkward things that we have to do. This is because I still haven't had time to build a tool for just generating these pages with a command line, with a single command. So we have to be manual in terms of adding the option to the sidebar so that you can actually see it. Just copying the pages, unfortunately, not enough right now. So in source pages layout, and then we have here the dashboard layout, you have the sidebar links. So we need to add a new sidebar link. So sidebar links are also view components that have these predefined parameters that you need to pass in. Let's call this events. So there are these icons, and I happen to know that sorry, that icon bell 55 is the one we want, and then we can just say events, right? So we added it to the sidebar, but this is still not enough. We need to add it to the router, so that the router is aware of the route that will take us to events. So this is in router.js, where we will be adding a new path at the bottom. So path is events, name is events, and the component is events. So we need to import this component. Import events from at pages events. Okay. So you just follow the same process that's done for the block number. You import that component in router.js, and then you add a new element down here that will just list it. So again, this is going to be automated in the very near future. I don't want people to have to do this all the time. We can already test if our basic thing works now, and if I'm not mistaken, this should already be live here. Yeah, there we go. So why you didn't need to refresh this is because we are running the dev version through Vue's server, basically. And the server is a hot reload server, which will automatically apply changes done to the source code to the actual website that's open. So it'll automatically refresh in the background. And so we have the events already out here, and the placeholder value is there. So this already works. That's fine. So now to subscribe to the events, let's first make sure that our API, this we don't need anymore, this we don't need anymore. Let's first make sure that our API works properly. So this iterative development lets you helps you make sure that every part as you build it just flat out works. So let's see if we are reaching this state. Yeah, so this, we can't use await in a function that is synchronous. So by default, functions are synchronous, which means they wait for one another. And await keywords are only available in async functions. So we have to change the syntax of the subscribe function a little bit. You can do it like this, async function, like this. And so now we have the let my API, which means define the variable my API, and inside it we await for the API to be ready. So we wait for the API to resolve, to connect, and to be sure that the connection is established. Once done, we'll get the console log of done. So let's see if that works. There, it just reloaded. Let's see here. Come on. Done. All right. So we see here that it's done. So the connection is successful. Let me just zoom out. There we go. That's good. Okay. So we know that our API is working. This is fine. This is great.
Quick question, Bruce. How come my API is underlined there? What's the error that it's saying?
Yeah. So this
it's never used. I see.
Yeah. So it's complaining this is the linter that really wants every variable to be used. It's just being very strict in terms of good code.
Okay,
so
makes sense.
Yeah. It's not an error, but it's like a reminder. Remember to remove this or use it. Otherwise, it just uses up memory. So
cool.
Yeah. So now, in order to get some events, we need to. Let me just show you in the UI here. Developer chain state. No, that's going to be on RPC calls. That's going to be on system, and that's going to be on. No, that's going to be on chain state in system and events. So you can see here that unfortunately the API, because it's being rapidly developed and it's changing by the day, it is very difficult to get a stable version of it, and it's very difficult to document because things are changing very rapidly. The ecosystem is evolving very quickly. So there's no documentation on what exactly you can call from where. The best way to learn is to explore these developer screens and just go through each possible call or just read the source code. So the way to know that the events are stored at system events in the chain state is to literally just find them here. You can see here, this UI has just subscribed to the events. And as new events come in, because the block changes, this UI will also refresh. This is what's happening. So you can see here that these events are being refreshed every time the block changes. But since nothing is happening in the chain, nothing actually changes. Right, yeah, so we don't have, because this is the development chain. If you were using a live chain, things would be changing here because different extrinsics and different events would be firing. But we are running an empty chain that's running on empty. Every block is empty, every block is the same. So nothing really is changing here. Anyway, this is what we'll be subscribing to. We'll be listening to these events produced by the system palette. Weird. So now we know that we have our API, right? So we have this done. And now there's this snippet of code that is actually listed as a demo in the Polkadot JS API docs. So let me just copy and paste that from there because it's ludicrous to just type it out. There we go. The docs changed recently, so let me just real quickly try and find this overview, basics and metadata. So these docs, let me just share the URL here as well. There we go. Providers, API, query subscriptions. Subscriptions with params, multiple queries, RPC queries, state queries. Damn it, where are your events? I can't find it right now, so I will take it. I will hand code it here, so it doesn't matter. We'll do it. So we have here every my API instance then exposes all of these calls that you can do here. So this is going to be chain state, extrinsics, RPC calls. If you want to query the chain state, you use the query object on the my API object. So that'll be my API.query. And then inside of that, we said we wanted system events, right? So this is automatically a subscription. And now inside of it, we put a callback or a function that will react to the events it gets from this. So that's going to be events. We'll get actual events from this. Okay? And we will be getting this like this. So, let's try and log something out, and let's do this like this. So we've received events length of events, something like that. Let's see if that does anything, if that works. There we are. Received 2 events. All right, cool. So we got 2 events from this by grabbing this way. Now let's see what they are actually. Let's move this and let's put a colon here just for visuals. So now we can output the events that we got from this. So we'll do events for each, and in each of these events, again, this takes a callback for each record that it gets in. And so now we are going to iterate through these events that we got, and we will expose their details. Every event has some sub elements of its own that you can extract like this. So const event and phase, and so then you get basically if you extract those from the record, every record has an event and a phase. These are just field values inside of this element. This is an element, this is an object that has the property event and the property phase. And you can find this out by literally going into the types of the API and reading about it, or just reading the docs. A lot of it is documented in the docs. It's just that they changed the doc generator recently, so there's no search. It's kind of difficult to use right now. It'll get better. So we extract the event and the phase, and we can also extract, so every when you're using Rust, when you're using Substrate, you define is a strictly typed language, right? So you will have very strictly defined types in Rust, and those are the developer of the Polkadot API tried to translate those to the API to TypeScript as faithfully as possible. So you will have each chain accompanied, each chain's metadata will be converted to types that you can expect in TypeScript. And these type definitions are something you can extract from every value that you get from the chain. So this is something like this. So now we can log those. And again, let me know if I need to slow down for any of this, if you're following along. So now we can log this something like this. Let's see how we can extract event section. So the section is another property of the event property that we extracted from this. So you can see this is a deeply nested element that you can actually, if you just expose this with if you just turn this record into a JSON string and log this into the console, you will see this entire object. It'll just get rendered as an object, right? So we'll put it something like this, event method. And then, so event has a section and a method, and that's going to be system and that's going to be the module and the function of that module that caused this event. So in the case of system remark, for those remarks, it would be system remark. And then we can maybe use something like this. So this is going to echo the phase in which this event is, and this means the phase of completion, like how far along is this event, what is it doing. Let's see what that looks like, if that works. There we go. So you can see here we got two events. One is system extrinsic success, and that's the event that we saw previously in our block. Come on, extrinsic success. Two of those are extrinsic success, right? And now if we compare this to here, this one is in phase 0 and this one is in phase 1. What does phase mean? Phase is actually this. This is phase 1, so this is the index in which it appears in the block. This is phase 1 and this is phase 0 and this is phase 1. And this is how you can match up events to extrinsics. So you have an extrinsic in phase 1 and an event in phase 1. That means that these match. So this is how you do it. This phase is actually the index of appearance in the block. All right, so then let's see what else we can output.
Hey Bruno, I just want to jump in. Like I'm so fascinated with what's going on. I just also want to. I know you had like a bit of time constriction, so I just want to point out the time where I'm happy to keep going with you, but just wanted to point it out for you if you needed to jet in any way.
Thank you. Yeah, I'll try and wrap this up real quick and leave you with some resources. We'll go through this completely and see how it works. Well, I can spare a few more minutes.
Sweet. I appreciate it. This is so good.
So now I outputted the meta documentation. So every type that comes out of the metadata of a chain also has its meta documentation that is contained in the Rust source code of that chain, and that's automatically exposed. You don't have to do anything special in Substrate while building your chain to expose this. You have to put in doc blocks like any good developer, so you have to document your code, but that documentation is automatically going to be exposed in this. And this is the meta documentation that we just got. An extrinsic completed successfully. So this is the description of this event that we just got. So that's the documentation that I exposed here. We don't really need this. This is just Flare, so it doesn't matter. And now, actually, let's not display any parameters, arguments. You can go deeper into this, get arguments out, get a lot of different stuff out. So we won't need the types for this. Let's try and get this displayed on the screen, right? So let's first we will need the block number, right? So we'll need the block number so we can match events to the block. So let's see. Let's get the header of the block, and now the header of the block is not under chain state because chain state only stores the latest state, and that doesn't contain block headers. This is under RPC calls. So if you go to RPC calls and then find the chain value, and then under chain you get the get block thing, this will let you get the header of the chain. So let's do this. So we'll get my API RPC chain and we'll get header. So now we have the block header, and from that header we can get block number. We can get the block number. So that's going to be header to JSON. So turn the header into JSON, and then you extract the number out of this. This is it's as simple as it gets. Again, we have the problem of not being able to use await because this function, this is actually a function, is not asynchronous. So we can get around this by just putting async here. That's JavaScript. So we have the block number, right? And now we can output the header, the block number for each set of events that we get, right? So now let's package those up like this. Let's do an empty array of events, and now we have an array into which we can collect these these events. So if we put this down as a message, event array push this message, our event array will be populated for each of these blocks, right? So each block will have a populated event array. And now we need to populate. So if we want a key value store of this, we need this to turn into an object. So we are now going to map each block number to the array of events in that block. And the way we're going to do this is after this loop, I think that's this, after this loop, we're going to call this and set. Now this set thing is a caveat of Vue.js. If you just assign it to this variable here, Vue doesn't know that this changed enough to change the rendering in our template. So this is just, if you Google Vue.js reactivity in depth, that's going to explain why this is necessary. It's just a trick that you need to keep in mind. So you pass in the object that's having its value set, you pass in the key, and you pass in the value. And so this should now work and populate our events object. We should remove the block number. We don't need it anymore. And finally, we do need to echo these events out. So this is a class. So we are already importing a card. So let's do a card. And this card is going to do this for us. So for each, so Vue has this v4 looper, which will let you iterate through some values in the JavaScript part of the component. And so we can iterate through each event and block in events. So this will iterate through the events object. This will iterate through the keys and the values of this thing that we pass in. So we can expose the block here, and we can make a paragraph that will echo each event separately. Let's say like this. So this should work, and then we can just expose E, right? What does this complain about? V bind key custom elements iteration require V bind key directives. Do they really though? Event block. This might be a version upgrade that I'm not familiar with. Let's see what happens if it broke or if it's working. There we go. It works. It's the layout is broken, but it does produce events. But the layout is kinda messed up. I should probably edit the template to fix this. So now the thing is that when you're connected to this will stay subscribed to these events. This will keep outputting them as they happen. And when you navigate to and from this page, this means that you will repeatedly call this subscribe. And if you repeatedly call this subscribe, you will subscribe multiple times, and you might blow your memory, and your site will die. So we need to make it. We need to create an unsubscribe function, and you do this because every Vue component, when it is removed from the screen, a lifecycle hook called before destroy is called. And this will automatically be called when you navigate away from a Vue.js page. And so we can just call unsubscribe here, and then we need to write the unsubscribe method. So let's do that right now. This is going to be in methods subscribe. Okay, unsubscribe, and that'll be a function which so I'll explain this in a second. So this is how it works. This unsub is going to be a value that we're going to put into our properties of our component. So unsub is going to be null, and our subscribe function, when it's done with the events subscription call, we will tell it that this unsub value that it produces, this is the output of the subscription call, will invoke a function that will just do this. So this unsub equals unsub. So what this does is when the function subscribes to events, the result of that subscription will be a function called unsub. And if you call that function, it will unsubscribe from listening to events. So we assigned this function to our properties variable called unsub up here. And then when we destroy this component, we call unsubscribe. And unsubscribe checks if this unsub is set to anything other than null, which means that we are subscribed because this was set, then call this unsub and kill the subscription. Otherwise, do nothing, right? And so this is all there is to it. And you now have the subscribe and unsubscribe flow of Polkadot event. Let me see if I can just quickly fix this layout. I don't know, 6 maybe, 6 like this. That's better. Okay, so now we have these events, and we should be getting, there we go, unsubbed. So now it unsubscribed from the subscription of events. But if we go back in here, we now have again the subscription is active. This is still outputting the stubs because we deleted the message and put it into the output of the template, but that's essentially it. So I'm a little bit out of time, but if you want to follow along with similar components, I suggest you go to .leap.com. There are a few tutorials here that focus on this stuff. So we have here this events tutorial that I just went through. It's similar to what we just did. You also have how to build a Substrate address translation filter, so you can convert a Kusama address to a Polkadot address to an Edgeware address and so on. And then there's some like how to read identities. So in this one, which I think is particularly interesting, but it takes a little bit longer, you read identities of people from the chain. And identities are a special palette that let you register real-world information on your on-chain account. And this is useful for validators who need a kind of proof of identity so that people trust them more and nominate them when staking. So this basically lets you query and look up some identities on chain and render it in a card in your own UI. And I encourage you to look at this, to play around with this, or maybe even to expand on the events example and build it for Remark, because we now know that Remark extrinsics to register these NFTs are contained in system Remark. Then we can actually see how you can build tools to display these NFTs and to extract them from the network from these remarks. So try and play around with that, use your creativity, and get in touch if you get stuck. If you need any kind of help, I'm there to lend a hand and to clarify anything that you might be curious about. I'm sorry we ran out of time. Maybe we'll have time for another crowdcast in the future. But yeah, thank you everybody for your attention, and yeah, get in touch. Keep hacking.
Yes, awesome. That was amazing. I really appreciated you coming out today and running us through that workshop. And of course, we would love to have you do another workshop. We have some space still in this hackathon, but of course, we'll be working together for our future hackathons. So thank you very much, Bruno, for your time. If you have to jet, you can jet. I did just want to do some wrap up with the folks here. So I want to thank everybody that tuned in today. This is going to be posted immediately after we finish the live, so you can go back and go at your own pace through this workshop. So that's always there for you. And of course, we're in the Discord ready to help you with any kind of issues that you have moving forward. You can find the link to all our resources just below here. There's a Blockhack Global Resource Hub. That's our portal. You'll find links to our Discord. And if you haven't already signed up for Blockhack, it's still not too late. There's time to build a business in the blockchain space and build a pitch deck so that you can get some seed funding to continue building on into the future. So check out our resource hub. And let's take a quick peek at our polls before we finish up. We had a good group of folks here. Lots of basic folks that have dabbled in Substrate, and we have some builders. And one person didn't know that or thought that Kusama is just a test network, but we talked about that today. It is a canary network. It is a live network all on its own. It has its own token. It has its own democracy going on. It's very, very interesting. You should check it out. And when you do, expect chaos. That is the motto of Kusama. So expect experimentation, and that's a great place to get your hands dirty and get involved. So on that note, I want to thank you all again. Thank you, Bruno, for tuning in. And we'll be back again in 2 more days with another set of amazing workshops and talks for you guys. So be sure to give us a follow on our Crowdcast to stay notified as we put these out. And until then, I'll see you in the Discord, and I'll see you in the next workshop. Take care, guys.
Cheers. Bye,
Thanks
guys.
again, Bruno.